German soldiers manning the Atlantic Wall in 1943 felt supremely confident. They clutched their Karabiner 98K rifles with pride. These weapons had conquered most of Europe. Why would they need anything else? Obergefreiter Hans Müller checked his bolt-action rifle one more time. He had trained with this weapon for years. He could work the bolt smoothly, even under stress. Like most German soldiers, Hans understood the rhythm of combat. Fire. Work the bolt. Aim. Fire. Again. Across the English Channel, American factories were producing something revolutionary. Thousands of M1 rifles rolled off assembly lines every day. But the Germans paid little attention. They had bigger concerns than American gadgets. The story of this revolutionary weapon began decades earlier. Not on European battlefields, but in a small Canadian farming town. John Garand was born on New Year's Day, 1888. His birthplace was Saint-Rémy, Quebec, just 17 miles south of Montreal. Tragedy struck when John turned 11. His mother died, leaving 13 children on a small farm. The family packed up and moved to America. They settled in Danielson, Connecticut, a typical mill town. Young John found work as a bobbin boy at age 12. The work was hard. The hours were long. But John loved the machinery around him. He studied steam engines during his breaks. He examined gear systems and complex mechanisms. His supervisors noticed something special about this boy. He suggested improvements to machines that had run the same way for years. John never received formal engineering training, but he learned something more valuable. He understood how mechanical systems worked. He grasped the principles of energy transfer. Most importantly, he learned that every problem had a solution. As John grew older, he expanded his skills. He worked as a machinist and toolmaker. Eventually, he found work at Brown & Sharp in Rhode Island. This company made the finest precision instruments in America. John developed a passion for firearms during these years. The early 1900s were exciting times for weapon development. Smokeless powder had revolutionized ammunition. Machine guns were becoming more sophisticated. By age 18, John had already patented 2 inventions. These early patents showed his ability to see problems from new angles. When America entered World War I in 1917, John saw his chance. He submitted a machine gun design to the Navy. They rejected it. But Navy officials were impressed with his work. They offered him a position as a weapons designer. John was assigned to Springfield Armory in Massachusetts in 1919. This was the heart of American small arms development. For John, it was like getting keys to a mechanical wonderland. Springfield Armory faced a crisis in the 1920s. During World War I, they had failed to meet production needs. The military had relied on British and French suppliers. This damaged the armory's reputation badly. John quickly realized the real problem. It wasn't just about production capacity. It was about fundamental design philosophy. The Springfield M1903 rifle was excellent by old standards, but it was a product of 19th century thinking. The M1903 was a bolt-action rifle. Soldiers had to manually work the bolt between every shot. They had to lift the handle, pull it back, push forward, and lock down. This took precious time during combat. More problematically, each rifle required hand-fitted parts. Skilled craftsmen assembled them carefully. This worked fine in peacetime. But modern wars needed millions of weapons fast. John understood the solution wasn't improving the old rifle. It was completely rethinking what a military rifle should be. He began envisioning a rifle that used firing energy to cycle automatically. The concept wasn't entirely new, but earlier attempts had serious problems. They were too complex, unreliable, or inaccurate. The challenge was creating something simple, reliable, and accurate. John began working on designs in 1919. His early concepts drew on steam engine principles. He realized gunpowder explosions created enormous gas pressure. This pressure was normally wasted after bullets left barrels. If some gas could be captured and redirected, it could operate the rifle automatically. Over several years, John refined his design through countless tries. Each prototype taught him something new. Some designs were too fragile. Others were too heavy or complex. Still others had accuracy or feeding problems. The breakthrough came in the mid-1920s. John developed the long-stroke gas piston system. A small port near the muzzle captured gas pressure. This gas drove a piston backward. The piston connected to an operating rod. When the piston moved back, it pulled the operating rod. The rod connected to the bolt mechanism. This provided enough force to extract spent cases. It ejected them, cocked the firing mechanism, and loaded fresh rounds. All this happened automatically in fractions of seconds. Soldiers could fire again as soon as they pulled triggers. But John had to solve another problem too: how to feed ammunition efficiently. Traditional rifles used internal magazines loaded one cartridge at a time. John developed an innovative system using en-bloc clips. Metal clips held 8 cartridges. They inserted into rifles as complete units. When soldiers inserted clips, entire clips went into internal magazines. As rifles fired, cartridges stripped from clips one by one. When the last round fired, empty clips ejected automatically with distinctive ping sounds. This system allowed very rapid reloading. Trained soldiers could reload in 2 or 3 seconds. It ensured soldiers always knew when rifles were empty. Bolts locked open and empty clips ejected. But John's design faced institutional resistance. Senior officers were skeptical of semi-automatic rifles. They worried soldiers would waste ammunition. They questioned whether complex mechanisms could be reliable. The caliber debate proved particularly tough. John's original design used a new .276 caliber cartridge. It offered superior ballistics and lighter weight compared to standard .30-06 ammunition. Military testing showed the smaller cartridge was more accurate. It created less recoil, making rapid fire easier. But in 1932, General Douglas MacArthur made a crucial decision. He ordered all .226 caliber development stopped immediately. John's rifle must be redesigned for existing .30-06 ammunition. MacArthur's reasoning was logistical. The Army had enormous .30-06 stockpiles from World War I. This decision forced John to redesign major portions of his rifle. The more powerful .30-06 created higher pressures. It required stronger components and more robust engineering. But John persevered. By 1932, John had developed the T1E2 rifle. This robust weapon was chambered for .30-06 cartridges. It underwent extensive testing at military facilities nationwide. Testers buried it in sand and soaked it in salt water. They froze it in sub-zero temperatures. They fired thousands of rounds without cleaning or maintenance. The results were impressive. The T1E2 proved remarkably reliable under terrible conditions. Its accuracy matched the best bolt-action rifles. Its rate of fire was more than triple that of conventional rifles. On August 3, 1933, the Army officially adopted John's design. It became the semi-automatic rifle, caliber .30, M1. But adoption was one thing. Production was quite another. Springfield Armory's facilities were geared toward slow, craft-based production. Creating infrastructure for mass production required complete transformation. John found himself designing entire production systems. He developed new manufacturing techniques. He created specialized tools and gauges. He trained workers in precise tolerances required. This work was as innovative as the rifle design itself. Production began slowly in 1936. Only a few rifles completed each day. But, as workers gained experience, output increased. By 1940, Springfield produced several hundred M1 rifles daily. Meanwhile, German military leaders watched American development with little concern. The German army was well equipped with Karabiner 98K rifles. These were excellent bolt-action weapons, accurate and reliable. German doctrine emphasized disciplined, aimed fire rather than rapid shooting. German soldiers trained to make every shot count. Officers believed slower fire promoted better marksmanship. The idea of American semi-automatic rifles was interesting, but not threatening. German confidence reflected broader faith in their military systems. The Wehrmacht had achieved stunning victories using conventional rifles. Some German engineers worked on semi-automatic designs, but these projects received low priority and limited resources. Why fix something that wasn't broken? This confidence would soon face its ultimate test. Pearl Harbor on December 7, 1941, transformed American rifle production overnight. Springfield Armory shifted to round-the-clock operations. By early 1942, American soldiers received M1 rifles in significant numbers. Training programs revised completely to teach proper handling. Many older soldiers initially preferred bolt-action simplicity. But as soldiers gained experience, attitudes changed. The rifle's advantages became apparent immediately. Soldiers could engage multiple targets much more quickly. They maintained better situational awareness. The ultimate test came in European mud and forests. German soldiers armed with trusted Kar 98K rifles would face Americans carrying John Garand's revolutionary design. As dawn broke on June 6, 1944, the stage was set. An armada of Allied ships stretched beyond the horizon. Operation Overlord was finally beginning. Obergefreiter Hans crouched in his machine gun position overlooking Omaha Beach. His Karabiner 98K leaned against concrete beside him. He understood bolt-action combat rhythms. The pause between shots as soldiers cycled rifles manually. What Hans didn't know was revolutionary. Many Americans wading through surf toward his position carried weapons that would change that rhythm forever. As landing craft ramps dropped, distinctive M1 cracks joined battle symphony. Private Robert Chen of the 1st Infantry Division had trained with his Garand for over a year. He checked his rifle one final time. German reaction to rapid M1 fire was confusion rather than alarm. In battle chaos, defenders assumed they heard multiple soldiers firing in sequence, not individual soldiers firing semi-automatically. The steady crack, crack, crack was unlike anything they'd experienced. Hauptmann Friedrich Weber commanded Atlantic Wall defenses. His after-action report described impossible rifle fire volume from small American groups. Weber initially ordered concentration on assumed machine gun positions, only to discover rapid fire came from individual riflemen. M1 advantages became apparent almost immediately. American soldiers engaged German positions with sustained rapid fire. While Germans paused between shots to work bolts, Americans maintained almost continuous fire. This proved invaluable in fluid beach assault combat. Sergeant William Thompson of the 29th Infantry described Omaha Beach experience. We were pinned by machine gun fire from concrete bunkers. With old Springfield rifles, we would have aimed carefully and hoped. But with Garands, we laid down walls of fire like having light machine guns in every soldier's hands. Germans couldn't stick heads up to aim properly. We put rounds downrange faster than they could react. The psychological impact matched tactical advantages. German soldiers accustomed to measured bolt-action pace faced opponents who fired almost continuously. Constant incoming rounds disrupted their return fire ability. But the true test came in brutal Normandy fighting afterward. The bocage landscape of small fields divided by ancient stone walls created close-quarters combat nightmares. Engagements often happened at 50 yards or less. Lieutenant Colonel Hans Richter's 352nd Infantry Division faced Americans in hedgerows south of Carentan in late June. His unit had fought Allies for weeks, but their first major M1 engagement caught them completely off guard. Richter's battalion established defensive positions along typical Norman hedgerows. Tactics were based on standard doctrine developed through combat experience. German soldiers would rise from cover, aim carefully, fire single shots, then duck down. These tactics worked against British Lee-Enfields and Soviet Mosin Nagants, both excellent bolt-action rifles requiring manual cycling. Germans learned to time movements during enemy bolt-working pauses. But when Americans attacked on June 23rd, familiar combat rhythms shattered. Americans appeared 100 yards away. Richter's men rose to engage them. Instead of expected single-shot exchanges, Americans immediately laid down stunning fire volumes. Where Germans expected several seconds to aim while Americans worked bolts, they found continuous incoming fire. This made accurate return shots nearly impossible. Unteroffizier Klaus Hoffmann told Allied interrogators his first reaction was assuming Americans brought machine guns. Only after examining captured equipment did he realize individual soldiers generated rapid fire with rifles. Tactical implications were profound. German fire and movement tactics relied on briefly exposing to shoot, then taking cover while reloading. But M1 semi-automatic fire compressed timing to make traditional tactics suicidal. By the time Germans rose, aimed, and fired once, Americans could fire 3, 4, or 5 accurate rounds. Brief German exposures became death sentences facing enemies with multiple rapid shots. The effect was most dramatic in meeting engagements, unexpected encounters between small groups in dense Norman terrain. Patrol Sergeant Franz Müller of 9th Taitwam SS Panzer described one near Villers-Bocage. His 8-man patrol moved through typical sunken lanes. They encountered a similar-sized American patrol. In conventional combat, such meetings resulted in brief, violent exchanges, then both sides taking cover. But this encounter followed different patterns. When patrols spotted each other, both immediately began firing. Müller's men fired initial shots quickly, then worked bolts for fresh rounds. In those few seconds, Americans fired multiple follow-ups. The engagement lasted only 30 seconds. Americans fired 60 to 70 rounds while Germans managed fewer than 20. 6 of Müller's 8 men were killed or wounded. The American patrol suffered 1 casualty. Such encounters became increasingly common as Americans pushed inland. German after-action reports consistently described surprise at American fire volumes. Unit commanders requested additional automatic weapons repeatedly. Urban combat in liberated Norman towns like Carentan and Cherbourg showed M1 advantages most clearly. In environments where engagements happened at 20 to 30 yards, rapid, accurate fire meant life or death. Hauptmann Wilhelm Fischer commanded company defenses around Cherbourg when Americans reached the city. His men fortified stone buildings for expected street fighting. German doctrine emphasized careful positioning and disciplined fire. Fischer's first M1 encounter shattered expectations. As Americans advanced, his men attempted carefully aimed fire from windows and doorways. But American ability to return multiple accurate shots immediately made positions untenable. Germans who fired from windows faced immediate suppressive fire. This prevented careful aim or remaining in position long enough to work bolts. Traditional fire and duck tactics became impossible. More importantly, M1 rapid fire let Americans maintain suppressive fire while comrades maneuvered. In bolt-action combat, Keeping enemies down required multiple soldiers or machine guns. Individual Americans with M1s could suppress effectively alone. German response was swift but inadequate. Field commanders requested more submachine guns and assault rifles. The Wehrmacht accelerated Sturmgewehr 44 development, but production remained limited. Most German soldiers continued relying on bolt-action rifles throughout the war. Training began emphasizing different tactics, like grenades and close assault, but adaptations came too late and weren't implemented widely. As war progressed, M1 tactical superiority became even more apparent. Paris liberation in August 1944 provided another dramatic demonstration. Staff Sergeant Michael O'Brien described fighting in eastern suburbs. Germans set roadblocks at major intersections. With bolt-action rifles, we would have coordinated advances carefully. Multiple soldiers providing covering fire before assaults. But with Garands, individuals provided their own covering fire while others moved. Psychological effects extended beyond individual engagements to impact German morale and doctrine at higher levels. Wehrmacht intelligence reports consistently noted American firepower superiority and recommended equipment changes. Oberst Heinrich Wagner, commanding 716th Infantry Regiment, submitted September 1944 reports summarizing German experience. Enemy semi-automatic rifles provide significant advantages in small unit actions. Our soldiers report Americans maintain suppressive fire-making movement and return fire extremely difficult. German prisoners consistently showed healthy respect for American rifle fire. Many reported learning to avoid engaging Americans at medium ranges where Garand advantages were most pronounced. Gefreiter Otto Schneider, captured near Bastogne in December 1944, told interrogators, "We learned to fear American rifle fire. When we heard that rapid crack, 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 we knew we faced Americans with automatic rifles." The Battle of the Bulge in December 1944 provided final definitive testing. American soldiers faced Wehrmacht's last major offensive under worst conditions. Snow, freezing temperatures, and ammunition shortages tested everything. Sergeant James Patterson of 101st Airborne defended Bastogne during German siege. "We were surrounded and running low on everything. Every shot had to count, but we needed enough firepower to break German attacks. The Garand was perfect. It was reliable in cold. It fired fast when we needed rapid fire. But it was accurate enough for careful shooting when conserving ammunition." German forces attacking Bastogne faced the same tactical problems since D-Day, now magnified by winter conditions and American defensive preparations. Wehrmacht's final offensive showed even their best troops couldn't overcome semi-automatic rifle advantages. As European war ended in spring 1945, M1 impact on infantry combat was undeniable. American soldiers consistently outfought Germans in small unit actions. Rapid-fire capability played crucial roles in that success. General George Patton captured the significance perfectly. He declared the M1 the greatest battle implement ever devised. This wasn't hyperbole. It recognized that M1 fundamentally changed infantry combat nature. German soldiers who initially dismissed M1s as American gadgets learned through bitter experience. Technological innovation could shift battlefield power balances. The bolt-action rifle age was ending. The M1 story extends beyond wartime service. Development and deployment lessons influenced small arms design for generations. Semi-automatic fire principles became worldwide military rifle standards. Today, more than 80 years after adoption, M1 Garand remains one of history's most influential weapons. Its warfare impact extends far beyond technical specifications or production numbers. By proving individual soldiers could effectively employ rapid-fire weapons, M1 changed fundamental assumptions about infantry tactics, training, and organization. German soldiers who laughed at American ingenuity learned dismissing enemy innovations could be fatal. The rapid crack, crack, crack of Garand fire across World War II battlefields marked more than Nazi Germany's defeat. It marked a new infantry warfare era, an era where superior technology and wisdom to employ it effectively provided decisive advantages. John Garand's quiet, small arms revolution proved that even in modern warfare's chaos and brutality, patient engineering work could tip victory and defeat balances. M1 Garand helped win World War II and showed the world that warfare's future belonged to those combining human courage with technological superiority.